Systems of equations seem intimidating, but they're really just two lines graphed in the coordinate plane, and those lines typically cross. The solution is just the point where these two lines cross. Now, most of the time, you'll just be given two equations with no graph, and you'll be asked to find the solution. Here's how you do that. There are two methods, substitution and elimination. Let's talk about substitution first. Here we have two equations, x equals 3y minus 4 and 2x plus y equals 13. The whole expression 3y minus 4 can be substituted in for the variable x in the second equation because x is equal to 3y minus 4. Now we have an equation 2 times 3y minus 4 plus y equals 13. This is going to allow us to solve for y. We get 6y minus 8 plus y equals 13. Combine the y terms and we get 7y. Add 8 to both sides so that we can isolate the y variable. We get 7y equals 21. Divide both sides by 7. And we find out that y equals 3. Now all we have to do is plug 3 in for y to one of our original equations, and we get that x equals 3 times 3 minus 4. So x equals 5. The solution to this system of equations is 5, 3. What does that mean? Well, it means that the two lines represented by our two equations cross at the point 5, 3. If you're going to use substitution, make sure you use parentheses so that you'll remember to distribute. In the equation we just did, we used parentheses around 3y minus 4, so we remembered to distribute the 2 to each term. We got 6y minus 8, not 6y minus 4, which is a common mistake people make when doing substitution. Now let's talk about elimination. We have 2x plus 3y equals 13, and we have 4x minus 3y equals 5. These are two different equations, which means they're two different lines that probably cross in the xy coordinate plane. Elimination is when you combine the two equations and then you solve. So we are going to add these two equations together. 2x plus 4x equals 6x. 3y minus 3y equals 0y. And then 13 plus 5 equals 18. So we have 6x equals 18. Now solve for x. X is equal to 3. Now plug x back in to the original equation, and we get 2 times 3 plus 3y equals 13. 6 plus 3y equals 13. 3y equals 7. Y equals 7 over 3. Let's take a look at what this actually means. If we graph our two lines on the xy coordinate plane, you'll see that they cross at the point x equals 3, y equals 7 over 3. This is all systems of equations really mean. So how should you choose when to use substitution and when to use elimination? It's very easy to use substitution when a variable is already isolated, just like our first example where x was already isolated. X equals something, and so you can plug that something in for x in the second equation. Otherwise, I would recommend using elimination. So let's do a more complicated question. 2x plus 3y equals 13, and 4x minus 6y equals negative 10. Now remember, we're just graphing these two lines and trying to find the point where they touch. But we don't have to graph these equations to find the answer. We can do something much faster when we use elimination. Notice that we cannot simply eliminate one variable by adding these two equations together, so we need to multiply the entire top equation by 2 so that we can eliminate the y values. We have a positive 3y on top and a negative 6y on bottom. So multiplying the entire top equation, including 13, by 2, we have a new system of equations that is identical. 4x plus 6y equals 26. 4x minus 6y is equal to negative 10. Combine these equations together by adding them, and we have 4x plus 4x equals 8x, and 6y minus 6y equals 0y. So we have 8x equals 26 minus 10. 8x equals 16. X is equal to 2. Now plug 2 back into the original equation. 2 times 2 plus 3y equals 13. 4 plus 3y equals 13, 3y equals 9, y equals 3. So these two lines cross at the point x equals 2, y equals 3. If you want to practice these questions more, go to app.classictestprep.com and find the free study guides there. Let's talk about when there are zero solutions or infinite solutions. This is where actually knowing what these questions are talking about is really, really helpful, and it's why we've talked about these lines crossing at a point. If you remember that systems of equations are just lines crossing, then questions about zero or infinite solutions will make more sense. So when a system has zero solutions, that means the lines do not cross in the coordinate plane. The only way for that to be possible is if the lines are parallel. They never meet, they never touch, so there are zero solutions. Infinite solutions just means that the lines are overlapping forever, which is another way of saying they are the same exact line. Now, if you already know this, you're probably bored, but if you don't, this is really important. Remember that systems of equations are just two lines crossing. If they don't cross, that is called zero solutions because they do not ever touch. There's no point, there's no solution. If there are infinite solutions, it means the lines are always touching, which just means they are the same line. Let's take a look at a classic CLT type question. For what value of k does the following system of equations have no solutions? Remember, no solutions just means the lines do not touch. Lines that do not touch are parallel. So we need a value for k that results in parallel lines. Y equals 1/2 x plus 3 is one of our lines, and 4y equals kx plus 6 is our other line. We need a value for k that results in the equation having a slope of 1/2 because they would have the same slope but a different y-intercept. If we divide both sides of the second equation by 4, we get y equals k over 4x plus 6 over 4. Remember, all we need now is to have k over 4 equal to 1/2. So k is just 2 because 2 over 4 is equal to 1/2. If k is equal to 2, then both lines have a slope of 1/2, and they are not the exact same line, so they do not have infinitely many solutions. So these are parallel lines. They will never touch. The answer is k equals 2. If you want more questions like this to really help you prepare for systems of equations on the CLT, visit app.classictestprep.com and sign up for free.